All right, now let's take a look at question 19. This one states 0.9999999, etc. equals to 1. So if we view numbers as infinite series, then yeah, this is actually in fact true, as we'll show it. All right, so let's look at the solution. So solution is it's true. So we can write this as a geometric series. So let's take a look at this. So this is 5, 9. So we get 0.99999. This equals 2. You could write this as, I'll write this as 0.9. All right, so you could do as 0.9 and then, or yeah, just leave it as that, or even for more completeness, or actually no, we could just ignore the other part. So let's say we have 0.9, so we look at this part, then plus, take the same number here, 0.9, and now we're going to multiply this by 0.1 to the power of, well, 1. We'll just leave it at 0.1. So 0.1 times 0.9, this is the same as dividing by 10. So then this will get to this part here. This one right here is equal to 0.09. So we could, just for completeness, this equals to 0.9 divided by 10, which equals to 0.09. All right, so then that's this term. Then we could add the next one, 0.9 times it by 0.1 squared. All right, and now this part right here, this equals to, again, 0.9 divided by 100. Because this is going to be divided by 10 squared, that's going to be 100. Yeah, so each time you do that, it gets already at 10 squared. This equals to 0.9 divided by 100, and this equals to 0.009. Like that. That's this part right there. And yeah, we can see that it goes further and further. If you do the next one, it's going to be 0.9 times it by 0.1 cubed. And this is going to be, again, divided by 1,000. So that will be this part right there. All right. And so on. It's the next one to be plus dot dot dot. Here, I just moved everything over to the center there. Anyway, so now what this, we could write this as a formula. So this equals to the summation from n equals to, let's start at n equals to 1. Just make it the same as the geometric series format. So this is from n equals 1. So we have this as the initial right there, 0.9. Every single one has a 0.9. Times it by 0.1 to power of n. Initially 0, 1, 2. So we just put n minus 1. So when this is 1, this goes to 0. When this is 2, the second term, this goes 2 minus 1 is 1. And when it's 3, you subtract 1, so like that. It goes from 0 like that. All right, so we have this. All right, so now that we have this as a geometric series, we can we can sum this up. Let's put can. We can sum this up using the formula for the sum of a geometric series. And if we recall the geometric series, see where we can scroll over it. I'll just search geometric like that. All right, so there's a geometric series over here, and hide this. Actually, no, this is not the geometric series. This is the link there, but it's actually over here. So here's the geometric series. Recall geometric series, summation of n equals 1 to infinity of AR n minus 1. Yeah, this equals to A plus AR squared, etc. So it's convergent if the absolute value of R is less than 1, and its sum is this right here, A, the first term, divided by 1 minus R. And in our case, we have, well, R is 0.1. And it's going to be less than 1. So in our case, we can use this formula to get the sum of the convergent series. So, but if R is greater than or equal to 1, the geometric series is divergent. All right, so first term divided by 1 minus common ratio. So let's go back to the bottom there. All right, so we're back here. So let's sum this up. So we have, in our case, A. This is A. This is R. All right, R is 0.1. So we have A equals to 0.9, R is equal to 0.1, and this is, yeah, and we have the scenario where the absolute value of R has to be less than 1. In our case, it's going to be equal to, well, just 0.1, and it's less than 1. Thus, this is convergent. Yeah, so that's where it converges, like that. Make this better. Alright, so continue further. Now just sum this up. So put this all in just completeness form, just write it all together. So the summation of the geometric series right here from n equals to 1 of a r to the power of n minus 1, in our case is equals to 0.9, like that, n equals to 1, 0.9, times it by 0.1, let's remove this like that, 0.1 power of n minus 1, this equals to a over 1 minus r, in our case can be equals to 0.9 divided by 1 minus 0.1. And this right here is just equals to, well, 1 minus 0.1, that's just 0.9. Alright, let's just move this over here. So this equals to 0.9 divided by 0.9. So they just cancel. This equals to 1. Alright, so the sum is 1. Like that. Yeah, so there it is. That's true. So that's just a geometric series. According to, if you look at an infinite terms format, that equals to itself. Oh, well, that equals to 1. You can just round. Basically just rounding up.